The whole area of bit rates for video seems to be designed to confuse megabits, megabytes, memory card speed ratings, slow-mo and so on. But sadly, if you're a video creator, then you're going to need to get at least a little bit of a handle on this stuff. This is one area where computer technology really intrudes itself into the filmmaker's workflow. I'm no Kubrick when it comes to the creative side of filmmaking, I'm far from it, but I do know computer technology. So in this video, I'm going to clear up the whole mess of jargon and computer speak around bit rates. In digital media, and video recording in particular, there seems to be a lot of confusion about bit rates. And this isn't really surprising. It can get pretty technical, and there's really no reason for non-techie people like movie creators to be familiar with this stuff. And a lot of modern gadgets seem to go out of their way to make this even more complicated, with different devices measuring bit rates in different ways. And then sometimes it really gets unavoidably complicated, like when your camera shoots at one speed, but sets your recorded video to play back at a different speed. So bit rates can be a pain, but unfortunately we kind of really need to know how they work. You need to know how fast a memory card to buy and how large, and both of those things depend on the bit rate. In the same way, you need to budget for how much storage you're going to need in post. So I'm going to try to shed some light on this stuff. I'll explain the terminology, which really seems to be set up to confuse, and some of the concepts behind it. I'll show you how you can use bit rates in practice, for example, to calculate your storage needs, and even how to measure your camera's bit rate. So what is bit rate? Well, basically it's just the amount of data measured in bits going through some kind of process per second, which leads to the question, what is a bit? And why are data rates sometimes measured in bytes? Well, this confusion comes from clashing cultures in technology, which unfortunately have spilled over into video creation. So we kind of need to talk about this stuff. A bit is the smallest amount of data that a computer can process. It's just one binary digit, a 1 or a 0. Bits are really tiny and fiddly, so usually we group them together into chunks, and the smallest chunk we use is called a byte with a Y. A byte is just 8 bits. I really kind of feel I shouldn't even be going into this kind of detail, but unfortunately, if you're going to be buying memory cards, then you kind of need to know this stuff, as we'll see later. Even a byte is pretty teeny and fiddly. A byte, seen in decimal, can store a number between 0 and 255. That's 256 different values. So this is useful for something that doesn't have a huge range of values. A byte could be the level of one color inside a given pixel, for example, if you were shooting 8-bit video. There are standard notations for bits and bytes, but sadly this is something you need to watch out for. A bit is abbreviated as a lowercase b. A byte is abbreviated as an uppercase b. This is a major point of confusion, and you need to be aware of it because the difference is close enough to get them confused easily, but far enough to make a big difference. For example, let's say I tell you that a memory card has a speed of 80 megabits per second, but I use the wrong B, and you read it as 80 megabytes per second. There's no reason you wouldn't just take that at face value, but the speed of the card would only be 1/8 of what you expect, and that could trip you up pretty badly. So if you see someone online talking about megabits and megabytes, if the numbers seem a bit suspect, check them carefully. A lot of people get this wrong. For the kinds of data we're dealing with in video, we generally need larger units. So you'll see people using prefixes like kilo, mega and giga. A kilo anything is just 1,000 of them. A mega is 1,000,000, and a giga is 1,000,000,000. That's 1,000 million, not the old British billion. For the sorts of data that some cameras produce nowadays, you might also need tera, which is 1,000 billion. Basically, each prefix is 1,000 times the previous one. So a megabit is 1,000,000 bits, and a megabyte is 1,000,000 bytes, which is also 8 million bits, or 8 megabits. The abbreviation for mega is a capital M. A lowercase m means milli, which is a thousandth. So take care to get that right if you don't want to look daft. But if somebody tells you that a camera records 100 millibits per second, it's pretty obvious what they really mean. By the way, you'll sometimes come across binary-based versions of these units, where a kilo is 1024, and so on. I'm going to talk about that more in a later episode, but for now, the decimal-based units that I've described here are pretty much the rule when we're talking about bit rates. So let's get back to what bit rates are really all about. From a video point of view, the bit rate is just the number of bits of data written to your camera's memory card per second. Usually for convenience we count millions of bits or megabits per second, abbreviated capital M lowercase b/s. Unfortunately, memory cards are usually labelled in megabytes per second, abbreviated capital M capital B/s, which obviously causes a lot of confusion. So you need to be careful to keep these straight. You can convert easily enough, bits is just bytes times 8, but you have to know which one you're dealing with. So why do you care about bit rates? Well, there's a few reasons. First of all, the video bitrate you're recording dictates how fast a memory card you need. In fact, you need a memory card which absolutely guarantees to handle and store your video bitrate in the worst case scenario. Unfortunately, this is way more complicated than it sounds. I'm going to talk about it more in a future episode all about memory cards. The bitrate your video plays at says something about the quality of your video. If all else is equal, like resolution, frame rate, and the efficiency of your camera's codec, then your bitrate essentially tells you how much data is being used to store all the detail in each frame. That all else being equal bit is tricky too though, as we'll see in a later episode all about codecs. Your bitrate also tells you how much storage you need. Let's say your camera records video, any kind of video, 2K, 4K, 3D, RAW, whatever, at a given bitrate. That bitrate is literally how fast your memory card will fill up and how much storage you will need on your editing workstation. To make the number more useful, divide it by 8 to get a byte rate, then multiply it by 3600 to get the rate per hour, then divide by 1000 to make it from mega to giga. You can combine these together and just multiply by 0.45. Or if you don't need to be precise, just divide the bitrate in megabits per second by 2 to get gigabytes per hour. Easy peasy. Just remember that dividing by 2 does 3 things: bits to bytes, seconds to hours, and mega to giga. So a camera recording at a bitrate of 160 megabits per second would need about 80 gigabytes of storage for an hour of footage. This simple approximation overestimates slightly, which gives you an extra safety margin. The actual number in this case would be 72 gigabytes per hour. Planning your editing setup in advance can save you from getting bogged down partway through a project. So let's say that you're planning a 90-minute movie at a shooting ratio of 30:1. That's 45 hours of footage you need to find space for. If your camera records at 80 gigabytes per hour, for 45 hours you need to budget for 3.6 terabytes of storage. Of course, video projects vary hugely in terms of runtime, shooting ratios, and so on. But if you apply these simple sums, you should be able to get an idea of what your project will need. And of course, all of this depends on your bitrate. Shooting 8K RAW, for example, that 3.6 terabytes might be closer to 60 terabytes. And by the way, anytime you're calculating storage needs and stuff like that, always allow plenty of headroom. For a calculated need of 3.6 terabytes, I would buy a 5 terabyte hard drive, at least. Your estimates may be way too conservative. So bitrates are useful for a variety of things. But at least bitrate is bitrate, regardless of what mode you're shooting in, right? Well, a lot of the time that's true, but if you get into slow motion, then unfortunately things get a bit more complicated. Again. Everything looks good in slow-mo. Well, there are exceptions. But what does slow-mo do to your bitrates? So a movie is just a sequence of still pictures, and there's no way to know how fast you're supposed to look at them. Think about flipping through a box of photos. You can go as fast or as slow as you like. It's the same thing with a movie file. A movie file just contains a bunch of pictures, and there's nothing to tell a video player how fast it's supposed to be played, at least not in the movie itself. Now obviously this isn't very useful, so to fix this we put a little piece of data, just a number, in the file header which gives the preferred playback speed in frames per second. When you play a movie, the player just looks at that number and then it'll grab that many frames from the file per second and put them on screen. There's absolutely nothing else in the movie that changes depending on the playback speed, which makes slow-mo very easy. If you have a movie recorded at, let's say, 100 frames per second and you want to play it back at 25 frames per second for slow-mo, then all you have to do is ignore the number in the file header and play it back at whatever speed you like. And that's how we do slow-mo. At this point, I feel I need to put in a quick sidebar for Premiere Pro users. Don't use the interpret footage feature in Premiere Pro, even though it sounds like exactly what I'm talking about. It wasn't designed for this, and it will break things like speed ramping, proxies, and so on. Use the speed duration feature instead. That's what it was designed for. So if your camera can shoot at a fast frame rate, you can do slow-mo yourself pretty easily. But to make it even easier, a lot of cameras nowadays can sort this out for you. By using a slow and quick or slow and fast mode, or whatever they call it, the camera can slow down your footage in the camera. By which I mean, it can set the number in the file header to a speed different to what you actually shot at. To give an example, if you shoot at, say, 120 frames per second, then the camera saves those frames in a file exactly as normal, except it sets that one number in the file header to 24 instead of 120, or whatever speed you want. Then when you play the file, it will play at that speed, 24 or whatever. So okay, but what does all this do to bit rates? Well, there are now two bit rates we care about. There's the record bit rate, which is the number of bits your camera is writing to the memory card every second, and the playback bit rate, which is the number of bits you're going to be reading from your hard drive per second when you play the movie. Because the movie is slowed down by whatever the slowdown factor is, the playback bit rate will be that much slower than the record bit rate. Just to put it in concrete terms, if I record at 120 frames per second at a record bit rate of 540 megabits per second, and the slow and quick speed is set to 24, then when the file is played back, it will play at 24 frames per second, which is a fifth of the record speed, and the playback bit rate will be 108 megabits per second, which is a fifth of the record bit rate. So okay, but which of these bit rates should you care about? Well, the answer is either, depending on what it is that you're actually interested in. The record bitrate tells you how much data the memory card in your camera needs to handle. For my example, the bitrate is 540 megabits per second. Dividing by 8 gives me 67.5 megabytes per second. That's clearly more than a V60 card can handle, so for this mode I would need a V90 SD card. The record bitrate also tells you how fast that card will fill up as you record. 540 megabits per second divided by 2 gives us 270 gigabytes per hour of recording. The playback bitrate gives us an idea of the video quality that our viewers will see as they watch the slowed down footage. In this example, 108 megabits per second is a bit less than my camera's normal bitrate for 4K, but not by too much. Of course, ideally it would be the same, but that would require capturing a huge amount of data, and many cameras will compromise when shooting at fast frame rates. In other words, the bit rate doesn't always scale up with the frame rate. Or in even other words, the number of bits per frame doesn't necessarily keep up at high frame rates. The playback bitrate also tells you how much storage you will need for a given amount of finished content. In other words, how much space you will need per slowed down playback hour. In our case, 108 megabits per second divided by 2 gives us 54 gigabytes per hour of slowed down footage. So playback bitrate and record bitrate are both useful, but this needn't be too confusing. And as long as you know your slowdown factor, which you really should, then you can always work out one from the other. The important thing is to know which one you're dealing with. For example, this camera in slow and fast mode tells me a bitrate but doesn't say which one it is. When I set it to shoot for 24 frames per second playback, but with slow and fast mode set to actually shoot 120 frames per second, you can see that it tells me that the bitrate is 108 megabits per second. The clue here is that this is less than my normal record bitrate, so this must be the playback bitrate. I can multiply this by the slowdown factor, which is 5 in this case, to see that the record bitrate is 540 megabits per second. If in doubt, you can measure your camera's record bitrate very easily. Just set your camera to the mode you're interested in, then set it to record for some set time, like 100 seconds. 100 seconds is good because it's longer than any realistic buffer that your camera or memory card might have. And then just look at the size of the file you just created. Multiply the file size in bytes by 8 to get bits, and divide by your record time in seconds, in this case 100, and that's the number of bits of data that you wrote to the memory card per second on average. If you do this, you'll find that the bit rates advertised by the camera aren't exact. There is no way for the camera to predict just exactly how compressible a given chunk of video will be, so the advertised bit rate is more of a target. There's a wiggle room like 5%. Also, technically, by looking at the file size, you're measuring the video bitrate plus the audio bitrate, but in practice, audio is so small that this doesn't make much difference. The fastest record rate I've measured on this camera, outside of the RAW modes, is 545 megabits per second, which is about 68 megabytes per second. And that's why this camera asks for V90 SD cards for the fastest shooting modes. That's a lot of stuff to digest about bit rates, but hopefully I've made things clearer, not muddier. Mostly I think this stuff isn't really very hard once you've seen it clearly explained, which I think is something you don't find much on the internet. But bear in mind the difference between bits and bytes, and doing the sums to figure out what they really mean shouldn't be too much of a challenge. Slow-mo adds another layer of complexity, but if you bear in mind the difference between the record bitrate and the playback bitrate, then that should help. The notations that are used for this are yet another tripping point, but bear in mind the difference between a lowercase b and an uppercase b, and you should be okay. Just bear in mind that not everyone on the internet gets this right. In any case, I hope this video has shed some light on this rather messy bit of film production. And thanks for watching.